Direct and partial variation. Question number 2. Any straight line through the origin represents direct variation. True or false? If the statement is incorrect, then write the correct statement. Okay, so write down the answer. Stop the video meanwhile. And once you've written the answer, then look into my explanation. Here is my explanation. Question number 2 says, any straight line through the origin represents direct variation. It seems to be correct, because direct variation is a straight line. Second, it should go through origin. These are two basic conditions for direct variation. Okay, so let's draw some straight lines and see, does it apply to all scenarios or not? So we'll make few graphs here. So I'll make a couple of graphs here to show you whether all are direct variation or not. Okay, 1. A straight line going through origin. Is this a direct relation? Yes, it is. How about this? Let's assume this is going through origin, okay? And how about this line? And how about this line? As you can see, all the 4 lines go through origin. Do they represent direct variation? That is a big question to be asked, right? As discussed in question 1 also, we said that direct variation means 2 things. First, straight line. And second, which go through origin. Right, both the conditions are met here. Now, there was one more condition, 3, that y is equals to k times x, or the ratio of y and k. This can also be written as, we'll write it, or y over x equals to k. That means ratio, their ratio is constant. So these are actually 4 conditions which we should be looking into. Now, if I say this line, so you can take any 2 points here and you'll find that y equals to kx is true, it's constant. Now for this line, what is the k value? As x increases, y really doesn't increase, correct? K value is 0. So this cannot be a direct variation. So here we have a restriction that k is not equal to 0. Okay? And here, what is the problem? Here x is not increasing, but y is increasing. Do you see that? So there is no change in x, but y value is changing. Do you see that? So this is not representative of direct variation. So we can say this is not direct variation, and this is also not a direct variation. Since here there is no variation in x, and here there is no variation in y. Do you see that? Therefore these two being straight lines and going through origin, they do not represent direct variation, and therefore we will add one more condition to this, and that is very important condition, that our straight line should not be vertical or horizontal. So we say straight line should not be vertical or horizontal. That is kind of very important condition for us. Correct? Straight line should not be vertical or horizontal. Otherwise, the straight line going through origin will represent a direct variation. So these are not the cases. But yes, even if the line is going down, it represents a direct variation. The only thing here is k value is negative, right? Do you understand? So that is how we have to see, okay, our condition. When we write in terms of ratios, y over x equals to k, remember here x is not equal to 0 because we cannot divide by 0, okay, in this type of an equation. So therefore normally we do not write like this. We write as y equals to k times x. Okay, not like this. But it works. Ratios and rate, they work. Rate and ratios do represent direct variation, right? But the restriction is you cannot divide by 0. Therefore, in this kind of representation, x is not equal to 0. So we prefer to write like this. Y equals to k times x. Here, there is no restriction on x. If x is 0, y is 0, and the point origin is on our graph. Correct? I hope you understand what really direct variation is. Okay? Thank you.